All right, guys, we are on the back side of day 7 notes. We're just going to do these 2 questions. These questions have a lot of variables in them. However, they give you the formula each time. We just have to be careful about what goes in for what and then how to solve it. All right, so in number 2, it says that the temperature T of a given cup of hot chocolate, okay, after it has been cooling for lowercase t minutes, can best be modeled by the function below, where T sub 0 is the temperature of the room and K is a constant. Okay, so a lot of variables in there. And now they're going to go ahead and say that a cup of hot chocolate is placed in a room that has a temperature of 68. So if we go back up, that's the room temperature. The room has a temperature of 68. And so back up here, T sub 0 is the temperature of the room. So that T sub 0 is 68. So let's go ahead and state that. Okay. Then it says after 3 minutes, the temperature of the hot chocolate is 150. So after 3 minutes, and coming back up here, lowercase t was in minutes. So I'm going to go ahead and say that lowercase t is equal to 3 minutes. Okay. And then they said the temperature of the hot chocolate is 150 degrees. So if we go back up, I believe that's the very first thing that they told us, that the temperature, capital T, of a given cup of hot chocolate. So the temperature of the hot chocolate, oops, wrong color. I want that to match what I have up there. So the temperature of the hot chocolate is 150. So that's capital T. It's 150 degrees. Okay. And then they say algebraically compute the value of K. So that's what we're finding. So we can write K equals question mark. Okay, to the nearest thousandth. And there's our rounding directions. Oops. Okay. All right, guys, let's see if we can plug in and go ahead and solve for our one missing variable. So that's an ln. That stays. Parentheses stays. We said capital T is 150 minus T sub 0, which is 68. Close it, equals. Keep the negative. We don't know K, so keep K. But lowercase t is 3. And the K and the T are next to each other with multiplication in between, so maybe use a parenthesis. And then plus 4.718. All right, so now we're going to go back to the left-hand side and clean this up a little. We're going to keep this as ln. 150 minus 68 is 82. On that side, negative k times 3 is negative 3k plus 4.718. So you can see that k is our only variable, and this is what we have to solve for. So we're going to go ahead and subtract 4. Oh, we can't subtract 4.78 yet. All right, because we have nothing to subtract it from on the other side. So what if we do this? What if in our calculator we type in ln of 82 to figure out what that equals? And when we type that in, that's going to be 4.406 719 ... equal to negative 3k plus 4.718. Now let's go ahead and subtract 4.718. Now that we have something to subtract it from. And when we do, we end up with negative 0.311280 ... equal to a negative 3k. And we'll go ahead and divide by negative 3. Divide by negative 3. And k comes out to equal 0.1037602 ... And up here they said to the nearest thousandth, which is 3 places, but look next door, and we'll say k equals 0.104. All right, that wasn't that bad. Just a little substitution and some solving. The next part says that using this value of k, so we're going to go ahead and keep our value of k. Find the temperature T, so that becomes our question mark, of this cup of hot chocolate if it's been sitting in this room for a total of 10 minutes, which was lowercase t. Instead of 3, now it's 10 minutes. Express your answer to the nearest degree. All right, so we have to remember that our room temp is staying exactly the same. And so we have our 3 variables filled in and our 1 question mark. Okay, so now we'll go back up to our formula and we'll plug in with this information. So we'll keep our ln. However, we don't know this capital T anymore. However, room temperature is still the same, so still minus 68. We'll keep the equal sign and the negative, but our K is 0.104. Our lowercase t is now 10, and we keep the plus 4.718. All right, so this time we can't figure out the left-hand side because we don't know t to subtract 68 from it. However, on the right-hand side, we could type that all right into our calculator, negative 0.104 times 10 plus 4.718 to get a grand total of 3.678. Okay, so now we have to think, what are we going to do? And remember that when we get stuck with an ln, sometimes it's helpful to change it back into what it actually is. A natural log is a log with a base of e. So let's see if that helps us. Now that it's log with a base of e and I see my base, I wonder if I can get it out of log form, because I don't think I need logs because this is my exponent and I already know it, and logs are supposed to help me solve for exponents. So out of log form, my base would be e, my exponent would be 3.678, and that's equal to t minus 68. All right, I can now type this into my calculator. So I'm going to type in e raised to the 3.678 in order to get a left-hand side of 39.5671 equal to t minus 68. To solve for t, I'm going to add 68. And I get a capital T value of 107.5671 ... And they said to the nearest degree. So nearest degree would be the 7, but look next door, and that's going to change it to 108 degrees. And I believe we're in Fahrenheit. Did they say Fahrenheit? I don't think they did. All right, so we'll just leave it like that. Most likely, I would think that that's Fahrenheit, but all right, so that one's done. So not terrible. Okay, let's go ahead and try number 3. In number 3, it says that the Fahrenheit, this one's in Fahrenheit, the Fahrenheit temperature F of T of a heated object at time T minutes. All right, let's get our highlighter out. So we have Fahrenheit temperature F of T of a heated object at time, oops, I want a different color, it's a different variable. Time T in minutes can be modeled by the function below. F sub S is the surrounding temperature, and F sub 0 is the initial temperature of the object, and then K is a constant. All right, so I feel like we even have more variables than last time. It says coffee at a temperature of 195 degrees. Coffee, 195. That seems like that might be either F of T or F sub 0. It's not the surrounding temperature. I think surrounding temperature refers to room temperature. It's not a constant. It's not minutes. So maybe we'll wait and see if we can figure out the other variables. All right, so the room temperature, that's the surrounding one. The room temperature is kept at a constant of 68 degrees. That's tricky because then they use constant, and so people might think that that's K. But then they tell you the K value here. So I can see how that can get confusing. All right, so we're going to say F sub S, which is the surrounding temperature, which is our room, is 68 degrees. And then our K value, which is our constant, is 0.05. Then it says coffee is safe to drink when its temperature is at most 120 degrees. So that could be the temperature of the heated object. And then it says determine to the nearest minute. So that's minute. That's what we're trying to figure. That's what we're trying to figure out. So that's our lowercase t. So we can put lowercase t equals our question mark. How long will it take until the coffee is safe to drink? Okay, so we still have F sub 0, which is the initial temperature of the object. And we still have F of t, which is the Fahrenheit temperature of the heated object. And we have 195 and we have 120. So I'm going to say that the initial temperature is the higher number. And initial temperature is F sub 0, so this is 195. And then F of t is the temperature of the heated object, which is 120. Which makes sense because if you look at F of t, that's your y, kind of in the y spot there, F of t, and that's your output, and that's what you want your temperature to be or to come out as so that you can drink it. Okay, I think this makes sense. All right, let's go ahead and plug into our formula. And so F of t is going to become our 120. Keep the equal sign. F sub s, it's hard for me to say, is 68. Keep the plus sign. Parenthesis. F sub 0 is 195. Minus F sub s, which is 68. Keep the e. Keep the negative. K is 0.05 times t, which we don't know. All right, so that's what we get after plugging in. We cannot do anything with the left-hand side with the 120 equals, so we'll keep it. We're going to keep the 68, and we're going to keep the plus sign. But I can go ahead and figure out 195 minus 68 in parentheses according to PEMDAS. That should be done first, right? Comes out to be 127. And then E, and negative 0.05 times T is just negative 0.05 T. All right, so remember we're solving for T, which is an exponent, which means we need logs. However, I don't think we're ready for logs. I feel like we have too many extras. E is our base because the exponent is on it. And so that makes 68 and 127 extras. You can't add 68 and 127 because the 127 is attached with multiplication to the E. But I believe I can go ahead and subtract 68, get rid of that extra. 120 minus 68 is 52, equal to 127 e to the negative 0.05 t. And now we're going to go ahead and get rid of the 127. And 52 divided by 127 is 0.409448, equal to e to the negative 0.05 t. And now we are down to our three things. We have our base, exponent, and number, and now we're ready for log form. So we're going to go ahead and write the word log. Our base is e. Our number is 0.409 equal to negative 0.05 t. We changed it into log form so that we can go ahead and change this into ln of 0.409 equal to negative 0.05 t. So that we can type ln of 0.409 number in. And if you want, at the same time, you could divide by 0.05 after you type it in. And that's going to end up with our t value of 17.8588 ... They asked to the nearest minute. So that would be this spot. Look next door. It's going to round it up, and we'll say t equals 18 minutes. And this one's done. All right. So hopefully you guys see that when you're given those nasty formulas with all those variables, take your time, make sure that you're plugging in the right numbers in the right spot. Otherwise, it might not work out so well. All right, but after that, just kind of plug and chug and solve along. All right. All right, guys, I will see you on Unit 7, Day 1 notes.